Welcome, guys. Now let us have to study tutorial about resultants of four systems. Okay, so you have here Cartesian coordinate system by which you have here the vertical axis for the y-axis, and then you have here for the x-axis. Let's say you have here the resultant force F, and then you have here the horizontal component of that force F, and then you have here the vertical component of F with this angle in reference to horizontal axis. So by the trigonometric functions, we can compute the value of the component at the x direction or the fx component by just having this angle. Okay, so we could compute this one as the adjacent to this angle. We have it as the cosine theta. Cosine theta is adjacent fx over the hypotenuse f. So similarly for sine theta, the opposite side here, which is fy. Okay, so fy over f for us to compute the sine theta. So the components of fx and fy have here this component fx and fy, and have here separated here, have fx and fy, and then at a certain angle here, theta or theta x, we can compute from here the resultant force F by hypotenuse by Pythagorean theorem that the square of the hypotenuse is equal to the square of the two sides, and we can write it in this form: f squared is equal to the square of fx and then the square of fy. Thus we can compute for the value of f. And for the angle of this theta, this angle with respect to the horizontal axis, we can just simply have the tangent function. This theta is just equal to the vertical component or fy, and then divided by the horizontal component, which is fx. Okay, so for example, we have here a force system. You have here F force is equal to 390 kilonewton, and then T force, which is equal to 400 kilonewton, and then a P force which is equal to 300 kilonewton with this respective angle or angles. For F, we have this slope 12:5. Thus we can have 12 squared, and then 5 squared will give us 13. Okay. And then you have here this side, or this angle is 40 degrees from the x-axis, and for P you have 30 degrees from this x-axis. So our problem is just to determine the x and y components of each of the forces shown. So for the 400 kilonewton, where's the 400 kilonewton? Here, so 400 kilonewton, the function or the x component is just the cosine here. The x component is just the cosine of the T400. So cosine 40 degrees is just equal to Tx, or the x component. You can say Tx, or the x component, all over 400 kilonewton. We just write it negative, right? Because it is in this direction here, negative, and then this one is positive. Here also is positive, and here is negative. Okay, so you have Tx is negative 307 kilonewton. Now for sine theta, also here it's going down also. This is also negative. Ty, this is Ty, this vertical component, you can say it's Ty all over negative 400, which is the force. Now we can compute Ty is equal to negative 257 kilonewton. Now for 390 kilonewton F, this function, okay, this is the function for the vertical component, and this is the function for horizontal component, which is fx. We can have the relationship of this slope 5 is to the hypotenuse, which is 13, 5 is to 13, and then this horizontal component fx is to negative 390. Then we can compute fx is equal to negative 150. Similarly, for vertical component, we can just have a ratio proportion for the slope in vertical direction, which is 12 is to this hypotenuse, which is 13, and then you have fy, which is in positive direction, And then you have your 390. Actually, this is positive direction, but this is not negative. Okay, so this becomes a positive 360. Whereas this one's negative 150 because it's going in this direction. Okay, this is Fx going in this direction. And lastly, for 300 kilonewton, you have your cosine 30, which is Px, okay, which is positive because it's going in this direction positive. And then Py here, which is negative, which is also this one, Py, which is just the opposite to the angle 30 degrees, meaning it is will be computed by sine function, trigonometric function. Sine 40 degrees is equal to Py over 300, which is now negative 150. As I said, this is going in this direction, downward direction. The value is negative sign. Now, let us have another example here. You have here a 300, the triangular block shown in the figure is subjected to the loads of P, which is equal to 1,600 kilonewton, and F, which is equal to 600 kilonewton, as you have seen in this figure. Okay, so AB is equal to 8 centimeters, this one, and then BC is equal to 6 centimeters, and this side is 10 centimeters. Actually, this is a 3, 4, 5 special triangle. This is 3, 4, and then 5. So if you have 6, 8, this one is 10. So we are going to solve each load into components, normal and tangential to AC. Which is normal? Normal to AC is perpendicular to that of AC, and this one is the tangential. Okay, the free body diagram, as you can see here. If this is theta, it is automatically that the normal axis normal to this plane. Okay, this line normal to the plane is also theta to that vertical plane. So this is Pn, and this one is Pt. Now let us compute the component, normal component of P, and then the tangential component of P. So from here, if this is theta, this is also theta. Okay, if this theta, and then in other words, if this is Pt, this one is Pn. So that's why we have this one. This Pn, P, there is theta P. If we have this one, we have theta, then we can compute the normal component and then tangential component of P. Why? Because this is our theta. Okay? This is our theta. Okay. I have different approach actually to compute this one. Sine theta, if we consider this one, that what is the sine of theta? It's just the opposite, which is 8 over hypotenuse, which is 10. Sine theta is 8 over 10, or 4 over 5, which is this one. So from here, sine theta is opposite Pn over P. So Pn is the component that we are going to compute, and P is given to be 1,600 kilonewton, then we can compute Pn. Similarly, for Pt, you have cosine theta here, cosine theta, you have Pt over P. Cosine is the adjacent, so you have Pt over 1,600. Cosine theta from here is just cosine theta 6 over 10 or 3 over 5. So you have your 3 over 5. Your cosine theta is Pt over P. Then your Pt is equal to 916 kilonewton. And how about for F? So for F, you see, this is theta. This is also our, okay. If this is, I should say, if this is Fn, this one should be Ft. Okay. So this is Ft, and this one should be Fn. Okay. From this angle, the opposite of theta is Ft. Right? The opposite of theta is Ft. This is F. Okay. The adjacent of theta, here's the theta. Adjacent here is Fn. So this is Fn. Okay. But here actually we can already compute. Okay. Here we can already compute. Because here, okay, for Fn, it is just cosine. Cosine theta is equal to Fn over F. And then sine is the opposite. Sine theta is equal to opposite, which is ft over f. So that's why sine theta here is equal to ft over f, which is 600. Sine theta, what's the sine theta? This is 3, 4, and 5. What is the sine theta? Opposite over hypotenuse, 4 over 5. See, this is 4 over 5. Cosine theta is adjacent. This is theta. This is adjacent over hypotenuse, 3 over 5. So thus, we have also for Fn is equal to 360, and then Ft is equal to 480. Thank you guys. Don't forget to subscribe my channel for more tutorials and some useful discussion in the civil engineering education. And yeah, thank you. See you next time.